Okay, so let's take a look at some real AP questions. So f of x is a continuous function, so that's f of 2 equals 5 and f of 5 is 2. Let h of x equal f of x minus x. Explain why there must be a value r, right? So they should be thinking, oh, intermediate value theorem. For r is between 2 and 5, such that h of r is 0. Now, because they told us f of x is continuous, right? It says it right here, f of x is continuous. We are allowed to use the intermediate value theorem, okay? So, in order to prove that somewhere between 2 and 5, h of r is 0, we need to find h of 2 and h of 5 and show that 0 is in between those two numbers. Okay, so let's start with h of 2. So h of 2 equals f of 2 minus 2. F of 2 is 5, so that's 5 minus 2, which is 3. H of 5 is f of 5 minus 5. So that's 2 minus 5, which is negative 3. Okay, great, because 0 is in between 3 and negative 3. So perfect, that's what we want. So now to actually explain our answer, we would say, since h of x is continuous, and the reason we know it's continuous is because f of x is continuous, and h of x is just f of x minus x. So it's going to still be a polynomial, which will still be continuous. So since h of x is continuous, and we want to say that 0 is in between these two numbers. You can literally say that. 0 is in between h of 2 and h of 5. You can get fancier and say h of 2, which is 3, is greater than 0, which is greater than h of 5, which is negative 3. So 0 is between these two values. So since those things are true, then by the intermediate value theorem, and then just repeat this line. There must be a value, sorry, that says a value, my handwriting's really messy, r for 2 is less than r, which is less than 5, such that h of r equals 0. Okay, so since the function is continuous and 0 is between 3 and negative 3, by the intermediate value theorem, there has to be a value r between 2 and 5 such that h of r is 0. Okay, this one's a little tricky. I'm going to do it with you. Actually, try it first, and then we'll go over it. Okay, going over it. The function f is continuous from 0 to 2 and has values that are given in the table above. The equation f of x equals a half must have at least two solutions on the interval from 0 to 2, so if k equals. Okay, so if you want to see this visually, if that helps you, we're going 0, 1, 1k, we don't know where k is, and 2, 2. Oops, I put the 2. Okay, so we're going somehow from this point to this point, okay? But if we want to have 1/2, which would be here, right, 1/2, as a f of x equals 1/2 at least twice, that means we need to pass a half in between here and here and pass a half up to here. So that means that the k value must be something less than a half so that we're passing it twice. So the only number less than a half is 0. Okay, if you didn't want to draw it, just think intermediate value theorem to go from 1 to something and then from that thing to 2. So it's got to pass a half both times. So we must be going from above a half to below a half and then back up to above a half. Okay, try this one yourself. I think this one's a little easier, but go ahead and try it. Okay, the function is continuous, so we can use IVT and the closed interval from negative 3 to 6. So they're telling us our x values are ranging from negative 3 to 6, right? That's what's inside the function, including negative 3, 6. The y values are going from negative 1 to 3. Okay, so we need x between here, y between here. F of 0 is 0. We use no guarantee on that. Again, the intermediate value theorem just says it exists. It doesn't tell us where exactly it is. This is talking about the derivative. We haven't even learned that. From negative, all the y values have to be between negative 1 and 3. That's not necessarily true. We just know that every y value between negative 1 and 3 exists, but it could go below negative 1. It can go above 3. We just don't know that. Okay, these are the two that we want to look at. F of c equals 1. So is the y value of 1. Yes, that would work. For at least one c between negative 3 and 6. Yes, that works. The x values gives us a y value in this range. Let's check f of c is 0. That's in this range too, for at least one c between -1 and 3. So not necessarily. We only know between -3 and 6. So we don't know that's between this value. Okay, so that's the answer. Lastly, try this one, and then we'll go over it. Okay, let f be a function that's continuous, so we can use IVT. And if f of 2 is -5, f of 5 is 5, and f of 9. So I'm going to sketch it in case that helps. 1, 2, so f of 2 is 5. Oh, it's -5. Okay, it's -5. F of 5 is 5. It's 5. And f of 9 is -5. Okay, so somehow our graph goes like this. We don't know what it looks like in between, but it goes to these points. Okay, f has at least 2 zeros. Which one must be true? Must be true. F has at least 2 zeros. Yes, because you're going from -5 to 5, that's going to pass 0, and then 5 to -5, that'll pass 0. So yes. For some c between 5 and 9, f of c is 7. Okay, all we know for sure is that it's going to hit every value between 5 and -5. It could go up to 7 and then back down. That's totally possible, but it's asking which one must be true, and this doesn't have to be true. Could be true, it doesn't have to be true. And lastly, from some c between 2 and 5, f of c has to equal 3. Yes, that's true, because we got to pass every number between -5 and +5, which includes 3. Okay, so that's 1 and 3. Okay, that's it. Next, we're going to try delta math, but I'll do some sample problems so you know what to do on the next slide. So let's take a look at some real of 2 is 5. Okay. And show that. So let's take a look at some really